This question shows a velocity versus time graph that's a periodic function. It wants us to find an antiderivative for the velocity and calculate the first position after t equals 0 when the velocity is 0. So not talking about this point here, because it has to be a position after t equals 0. The question is referring to this point here when v is 0. It wants to know what is the position of the object. Alright, so the first thing I'm going to have to do is I'm going to have to find a formula for this function. And I could make it a sine or a cosine type of graph, whichever I choose. I'm going to make this a sine graph. So it's going to be v of t is equal to an amplitude times sine of omega t minus a phase difference. But in this case, we see that the phase difference is 0 because sine normally starts at the origin. And this graph starts at the origin, so there's no phase difference. Alright, so our amplitude is going to be the highest value that the velocity reaches. So that's going to be v max here equals 4. And so that's what's going to go in for A. Now in order to find the omega, the angular frequency, I could use this formula, 2 pi over t, where t is the period of the graph. So let's find the period here. The period is 1. That's how long it takes for the cycle to complete. So that makes our omega for this problem 2 pi. Phase difference is just 0. There is no horizontal shift of the sine function. So that's our velocity function. What I want to do now is try to construct a position function using the idea that the position is going to be an antiderivative of the velocity. So let's do an indefinite integral of 4 sine of 2 pi t. So I'm going to do a u substitution for this part of the problem. I'm going to let u stand for the 2 pi t. And so we'll be transforming this into 4 sine of u. I also have to find the derivative of this equation. I'll substitute in the 1 over 2 pi du in place of dt. Okay, now we can make this 4 times the antiderivative of sine, which is negative cosine. And we'll get that. So we'll have negative 2 over pi times cosine. We could get rid of the u and plug the 2 pi t back in. And that gives us our position function. And the question says to just let the constant of integration be 0. So there won't be any vertical shift of the function. It'll be centered around the time axis. Let's graph it and see what it looks like. First, I'll graph the velocity just to check to make sure that I had that plotted correctly. And so, yeah, for sine of 2 pi t, it does look like the picture in the question. So that's my velocity graph. Now let's plug in what I believe the position function to be. Okay, so the blue represents the position function. And what I should do now is figure out what the position of the object is at a t of 0.5, because that's the first time that the velocity is 0 after t equals 0. I could probably just click on this point right here. Yeah, that's going to be the position that is the answer to the question. 0.637. So at a t of 0.5, x of 0.5 equals negative 2 over pi cosine of 2 pi times 0.5. And it's 0.637.